We know that Earth orbits the Sun, along with 7 other planets in our solar system. But what about the planets outside of it? We are surrounded by billions of stars. How many planets do they have? And what are they like? Get ready for a wonderful adventure, because we will take you millions of light years away from our home and make several stops along the way to see how truly diverse the universe is. Imagine a world different from Earth, dark and hostile, where it rains glass or iron, the planet where any known metal just melts away. Beautiful new worlds that are more life-friendly than Earth, filled with oceans and land. Lonely and mysterious worlds, holding secrets well beyond our grasp. These are the kind of places that spark our curiosity. This is a journey to worlds outside the solar system, to exoplanets. Our Earth, the only heavenly body we know to host life. But there is a huge number of other planets that can also host life outside the solar system in deep space. Let's look at the southern part of the sky. There, you can see the most famous constellation of the southern hemisphere, namely the Southern Cross or Crux, and the Centaurus constellation located on Charles's Wain-Virgo line. To the south of the Centaurus constellation and to the left of Crux, there is the closest exoplanet to Earth, the mysterious Proxima Centauri b, which resembles our planet at the first glance. As you see, Proxima Centauri b always faces its parent red dwarf star, Proxima Centauri, with the same side. This is why one side of the planet is scorching hot and has many clouds, while the other one is always cold and cloudless. But what makes it so unique? Let's see. Proxima b is an exoplanet that rotates around its parent star, Proxima Centauri, which is a red dwarf and an M-type star. The discovery of this exoplanet was proved by a group of astronomers from the European Southern Observatory in August 2016. It was discovered using the radial velocity method, which makes it possible to detect a star by observing regular shifts in spectral lines of the star's spectrum due to the Doppler effect. Proxima b is 1.27 times heavier than Earth, and it orbits its parent star in 11.2 days. It is located approximately 4.22 light years, or 43 trillion kilometers away from the Earth. This is 266,000 times farther than the distance from Earth to the Sun. There is no day and night cycle on Proxima b, as it always faces its star with one side, due to being tidally locked, much like the Moon to Earth. This means that one side of Proxima b is always hot, while the other one is cold, with temperatures as low as absolute zero. The planet might have freakishly strong winds, that is, if it has an atmosphere. Proxima b is a rocky planet. It's located 7.5 million kilometers from its star. Despite being so close to its star, Proxima b is potentially livable as the temperature on the star surface is 2 times lower than on the Sun, and its mass is 10 times lower. But is it really livable? Let's take a closer look. Being just 4 light years away from Earth, Proxima b is our closest known neighbor outside the solar system. However, studying the planet's atmosphere is impossible with the use of standard methods. In this case, scientists have to rely on different Earth models to create several theories on what Proxima b might be like. This will help us understand whether the planet is livable. One of these models posits that Proxima b is a water planet with ocean circulation that has warmer currents moving to colder regions, but no land. Take a look at an oddly shaped exposed ocean covering the entire planet's surface. Another computer model looks at what would happen if Earth orbited Proxima Centauri, our closest stellar neighbor and a parent star of Proxima b, the same way this exoplanet orbits it, and the Pacific Ocean was on the star side. It might look something like this. The third model presented by the researchers hypothesizes what would happen if the Earth were in Proxima B's location and was also tidally locked with Africa on the star side. It would probably look something like this. The fourth model theorizes what Proxima B would look like if it was a water planet without any currents or dry land. Take a look at what the star side of the planet would look like. So, according to the predominant scientific theory, Proxima B has one main property which is also common to Earth. It orbits within the habitable zone of its star, meaning that the surface temperature makes us optimistic about the presence of water. Researchers suppose Proxima B might have a big 200-kilometer deep ocean covering its surface, and also a thin gaseous atmosphere, very similar to what we have on Earth. Furthermore, in the case the rotation is synchronous, the heat transfer between the dark side of the planet and the side facing the star should have made the entire surface of the exoplanet potentially habitable. Therefore, if Proxima B is proven to have atmosphere and water, it has a very high chance at hosting life. But there is some bad news. In 2017, a team of astronomers detected a massive stellar flare, a powerful burst of radiation coming from Proxima Centauri. In the light of this fact, the potential habitability of the exoplanet which orbits Proxima Centauri comes into question. At its highest brightness, this flare was 10 times brighter than the most powerful solar flares that have been observed at approximately the same wavelength. A powerful emission has increased Proxima Centauri's brightness by 1,000 times in 10 seconds. Before this, there was one weaker flare. The whole process took about 2 minutes. Such stellar flares take place when the magnetic field of the star changes, accelerating electrons almost to the speed of light. Accelerated electrons interact with highly charged plasma that the star is mostly made of, causing an eruption that spreads radiation across the whole electromagnetic spectrum. Most probably, Proxima B has received a high dose of radiation during this stellar flare. Moreover, several other X-ray flares have been observed on Proxima Centauri in the past. In billions of years of Proxima B's existence, this could have eradicated the atmosphere and ocean, wiping out all life on the planet. This planet seems bright blue to a regular human eye, but thinking that it resembles our friendly Earth would be a fatal mistake. This planet's atmosphere is deadly dangerous. Being caught in the rain here is more than just something uncomfortable. HD 189773b is located in the Vulpecula constellation at a distance of 63 light-years from the Sun. It is much bigger and hotter than Earth. This exoplanet was first discovered in 2005. It is well studied by Hubble and other telescopes, as it is relatively close to Earth. This is a massive gas giant orbiting very close to its parent star. A stunningly high 1,000 degrees Celsius temperature makes the planet's atmosphere steaming hot. HD 189773b is 13% heavier than Jupiter, and it orbits its parent star every 2.2 Earth days with an orbital speed of 152.5 kilometers per second, making this hot Jupiter a poor candidate for hosting extraterrestrial life. The planet's blue color is believed to come from silicate particles in the atmosphere, which disperse blue light. Because of the planet's surface temperature, the particles can condense, turning into glass. Then these glass seeds are being blown at a whopping speed of 2 kilometers per second. Now, isn't that absolutely breathtaking? The highest wind speed that has ever been detected on Earth is only 408 kilometers per hour, and this is 20 times slower than on the exoplanet. Our planet's regular wind speed is about several meters per second, but on this exoplanet, it's 2 kilometers per second, which is about 1,000 times higher. Being 7 times faster than the speed of sound, the cruel winds of HD 189773b would take any unfortunate guest on a deadly spiral around this planet. Using Spitzer Space Telescope data on infrared radiation, NASA's astronomers created a map of the exoplanet surface. It shows temperature fluctuations above cloudy peaks of this gas giant. Higher temperatures are highlighted here in brighter colors. HD 189773b, known as Hot Jupiter, orbits its parent star much closer than Mercury does our Sun. It has a high orbital speed and is tidally locked with its parent planet, much like the Moon to Earth, meaning that one side of the exoplanet always faces its star. The map clearly shows that HD 189773b has a warm spot on the so-called stellar side, the one that always faces the star. But the map also shows that this spot has shifted from the high noon point by 30 degrees. Scientists argue that the hot point has been shifted by the fierce winds to the east. What's more interesting, astronomers established that temperature indices on this planet are fairly stable. The dark side of the planet has a temperature of about 1200 degrees Fahrenheit, or 650 degrees Celsius, while the exoplanet's sunny side is 1700 degrees Fahrenheit, or 930 degrees Celsius. This moderate temperature variation is proving once again the presence of extreme winds, which help to transfer the heat from the hot and sunny side of the planet to its darker side. TRAPPIST-1 star was first discovered in 1999 by John Gieses and his team. Its name comes from a small telescope called Transiting Planets and Planetesimals that was used to detect it. This is a lonely star, with a planet system in the Aquarius constellation, some 39.46 light-years away from Earth. It is an ultra-cool red dwarf of spectral glass MV8. TRAPPIST-1's size is only slightly bigger than Jupiter, and its mass is about 8% of the Sun's mass, which makes it even cooler and dimmer. The star's radius is 12.1% of the Sun's radius, which is slightly bigger than that of Jupiter. TRAPPIST-1's age is estimated to be between 5.4 and 9.8 billion years. Taking the star's age into account is very important for understanding if the surrounding planets can be potentially habitable. TRAPPIST-1 is about twice as old as the Solar System, which was formed about 4.5 billion years ago. In May 2016, astronomers from ESO La Silla Observatory detected a dim and cool star fading at regular intervals, indicating that several objects were passing between the star and the Earth. The observation was made using the TRAPPIST telescope. A detailed analysis revealed that there are 3 planets resembling Venus and Earth orbiting the star. In July 2016, scientists used NASA's Hubble telescope to discover that these planets most likely don't have an atmosphere of prevailing hydrogen. Hence, these planets can be rocky and possibly have water on their surface. As early as February 2017, scientists announced the discovery of 4 more planets at a press conference by NASA. Thus, it became clear that there are 7 Earth-sized planets in the system. NASA's Spitzer Space Telescope, Transiting Planets and Planetesimal Small Telescope in Chile, and other ground telescopes were used to detect and characterize planets. Astronomers claim that 3 of these planets are in the theoretically habitable zone. All 7 exoplanets orbit TRAPPIST-1 and are currently labeled B, C, D, E, F, G, and H in order based on proximity to their star. The largest planets, G and B, are about 10% larger than Earth. The smallest planets, D and H, are about 25% smaller than our planet. Researchers determined that the farthest planet from the star, TRAPPIST-1H, orbits its star every 19 days using NASA's Kepler Space Telescope. This is still much shorter than the orbit of Mercury, which goes around the Sun every 88 days. But because TRAPPIST-1 is so faint, it outputs only 0.05% the amount of energy of the Sun, planet H receives a lot less heat than Mercury and may be covered in ice. The amount of energy per unit area that 1H receives from its star is comparable to that which the dwarf planet Ceres in the asteroid belt between Mars and Jupiter receives from our Sun. Among the 7 planets in the system, TRAPPIST-1b is the closest one to the star, with an orbital period of a day and a half. Its orbital radius is almost 100 times smaller than that of the Earth. The TRAPPIST-1 planets are so close together that if you could stand on the surface of one, you might see some of the neighboring planets hovering above. Scale-wise, the structure of this planetary system resembles the satellite system of Jupiter more than the structure of the solar system. Star TRAPPIST-1 is a small and relatively cool red dwarf star belonging to spectral class M. They are the most common stellar objects in the universe and make up 70 to 90% of all observed stars. There are 7 planets in the TRAPPIST-1 system, roughly the size of Earth. 3 of them are in the habitable zone, meaning their distance from their parent star allows them to have liquid water on their surface. And this can most surely indicate that red dwarfs have many Earth-like planets. After all, astrophysicists believe such planets to be the primary candidates for potentially hosting life outside the solar system. After discovering the TRAPPIST-1 system, researchers tried to study its stability using computer simulations with different initial conditions. However, the simulated planets almost always collided about 500,000 years after their origin, literally destroying the entire system. When assessing the planetary system's stability, the researchers concluded that there is a stabilizing factor. The researchers found out that the time it took for each planet to complete a circle around its star was of crucial importance. The thing is, their orbital periods make up a surprisingly accurate progression. For every 2 orbital cycles the farthest planet from the star completes, the closest one to it orbits the star 3 times, the next one 4 times, then 6, 9, 15, and 24 times respectively, thus achieving a 2 to 3 resonance, where the planet's orbital cycles reach a 2 to 3 ratio. It works like clockwork. There is no long resonant chain like it in other planetary systems. When you reproduce the way the model works, you get the system that sustains itself for as long as the simulation continues. In other words, each planet orbits the star in alignment with its neighbors in the system. Therefore, this unique property allows the entire system to exist for a long period of time, allowing scientists to observe it. The TRAPPIST-1 system contains a total of 7 Earth-sized planets. 3 of them, TRAPPIST-1d, E, and F, are in a potentially habitable zone, where the temperature is suited for having liquid water on the surface. Planets 1b and C are too close to their parent star, and 1H is too far away. The measured densities, combined with planetary compositional models, suggest that the surface of the TRAPPIST-1 planets is far from being a barren, rocky desert. Apparently, they contain a significant amount of volatiles and water, the volume of the latter reaching up to 5% in some of the planet's masses. This is a pretty high percentage. For comparison purposes, water constitutes only 0.02% of Earth's mass. TRAPPIST-1e is the only planet in the system that is slightly denser than Earth. This could mean that it may have a denser iron core, lack a thick atmosphere, oceans, or an ice cape. This planet turned out to be much more rocky than all the other planets of the system. In terms of size, density, and the amount of stellar flux, this planet is more similar to Earth than all the others. According to the Habitable Exoplanets catalog, TRAPPIST-1e is one of the most potentially habitable exoplanets discovered so far. TRAPPIST-1e is confirmed to have a compact, hydrogen-free atmosphere like those of our solar system's rocky planets, further raising the chances of habitability. Hydrogen is a powerful greenhouse gas, so if there was enough to be easily detected, it would mean that the surface of TRAPPIST-1e would be inhospitable. Since such an atmosphere is not present, It raises the chances for the planet to have a more Earth-like atmosphere instead. TRAPPIST-1F is the fifth farthest planet from its parent star in the 7-planet system. It has a diameter close to that of Earth, but is much lighter, weighing only 0.36 Earth masses. The low density of this planet most likely indicates a significant amount of water or other light substances in its composition. The estimated surface temperature is minus 54 degrees Celsius. TRAPPIST-1D is the third farthest planet from the star, with an average surface temperature of plus 15 degrees Celsius and slightly smaller dimensions compared to Earth. Its radius is much shorter than the Earth's radius, and its mass is only 0.33 Earth masses. TRAPPIST-1b and TRAPPIST-1c, the closest planets of the system to the parent star, most likely have a rocky core and are surrounded by a much denser atmosphere than Earth. According to density measurements, Planet B can either have a small core or, more likely, contain a significant amount of water or other volatiles in its composition. TRAPPIST-1H has the smallest radius and mass among its cousins. The surface temperature is estimated to be at a life-threatening minus 104 degrees Celsius. 1H orbits its star every 19 days. This is still much shorter than the orbit of Mercury. But because TRAPPIST-1 is so faint, it only outputs 0.05% the amount of energy of the Sun, Planet H receives a lot less heat than Mercury and may be covered in ice. In 2016, astronomers discovered an unusual planet by the name of Kelt 9b. Being the hottest exoplanet ever discovered, it's so hot that it literally rips apart its atmosphere's hydrogen molecules. What is this mysterious planet like? Let's take a closer look right now. The planet is close to Saturn, a bright star in the center of the Northern Cross. It orbits a star called Kelt 9, or HD 195689, about 620 light-years away from the Sun in the Cygnus constellation. The star Kelt 9 is only 300 million years old. It is more than twice as large and almost twice as hot as our Sun. The exoplanet orbits its parent star at 4.5 million kilometers. The star's temperature is 9,800 degrees Celsius, and the temperature on the planet itself reaches a whopping 4,300 degrees Celsius. In fact, this is hotter than most stars in the universe. For example, the surface temperature of the red star Antares is only 3,400 degrees Celsius. This is almost 1,000 degrees lower than on the planet Kelt 9b. And keep in mind that red dwarfs constitute about 30 to 50% of all stars. Currently, tungsten is the most refractory metal known to us, with a whopping melting point of 3,422 degrees Celsius. Even this metal would melt on this planet. Using the HARPS North spectrograph, astronomers have found spectral lines corresponding to ionized iron and ionized titanium atoms. These particles can condense on the night side of the planet, forming clouds that can make it rain metal. Being too close to its parent star, Kelt 9b is tidally locked due to gravitational forces, meaning that one side of the planet faces its star at all times. Interestingly, the planet receives 44,000 times more flux from its star than the Earth from the Sun. Scientists would expect the planet to have a smaller radius, but the extreme radiation from its host star has caused the planet's atmosphere to puff up like a balloon. The planet is 2.88 times heavier than Jupiter, and it's 1.8 times larger than Jupiter. Given that the planet's atmosphere is constantly blasted with high levels of ultraviolet radiation, the planet may even be shedding a tail of evaporated planetary material like a comet. The temperature on Kelt 9b is so high that the hydrogen gas molecules split into pieces on its day side and cannot reunite until their scattered atoms cross over to the night side of the planet. The night side cools down the hydrogen gas molecules just enough to make them recover. But as they return to the day side again, they split apart once more, and the cycle continues. There's one more peculiar feature that makes this planet truly unique, and that is its orbit. Unlike other planets that orbit the equatorial region of their parent star, it actually orbits the polar region. In other words, this planet is tilted in such a way that it has a polar orbit. But no one can explain why this planet came to have such an unusual orbital motion in the first place. As if this wasn't enough, its host star is an oddity too. The primary, Kelt 9, is roughly twice the size of the Sun, 56% hotter, and spins 38 times as fast. That makes for a complete stellar rotation in 16 hours. As you would imagine, the rapid spin causes the star to deform, flattening at the poles and broadening at the equator. As a result, we run into the phenomenon known as gravity darkening. The poles brighten as the equatorial region cools and dims by comparison. As a result, the temperature at the equator will be much lower than that at the poles. We are talking about 800 degrees difference. Such high temperature contrast creates very interesting effects. The planet orbits directly above both poles of the star. Just imagine, with Kelt 9b's orbital period of 36 hours, the planet goes through 2 summers and 2 winters, and each season lasts about 9 hours. This sequence illustrates a year as experienced by Kelt 9b. Because of the temperature differential on the surface of the star, the planet experiences an unusual kind of seasonality. Hotter over the poles, colder over the star's equator. Over the course of a single orbit, the planet twice experiences cycles of heating and cooling caused by the star's unusual pattern of surface temperatures. The next planet on our virtual journey is doomed to vanish in the next 10 million years. The planet is WASP 12b, a hot Jupiter of the most extreme kind. It is an ultra-hot, orange gas giant that is 1.5 times heavier than Jupiter. The planet was discovered in 2008 by the transit method. WASP 12b is located about 1,400 light-years from Earth in the Auriga constellation. The planet is about 3.6 million kilometers away from its parent star. To get a feel for this distance, let's see how close Mercury is to our Sun. The average distance from Mercury to the Sun is 57 million kilometers. That is almost 16 times the distance from WASP 12b to its star. Now, let's imagine we reduce stars and planets in scale. If the Sun were to be the size of a regular basketball, then this exoplanet would be 61 centimeters away from it, and Mercury almost 10 meters away. Keep in mind that this is the closest planet to the Sun. With an orbital period of just 1.1 days, WASP 12b is so close to its parent star that daytime temperatures reach 2,540 degrees Celsius, or 2,810 Kelvin. Its atmosphere swells up to 3 times the radius of Jupiter and spills matter onto its star. Sadly, the planet is doomed to die, as if devoured by its parent star. The extreme gravity is stretching the hot gas giant into the shape of an egg, all the while slowly cannibalizing the planet. Relatively soon, 10 million years, a fleeting moment in space-time, this planet will be completely devoured by its hungry star. If you enjoy watching the world fall to pieces, then this planet is for you. This is especially interesting, taking into account that something similar might have happened in our solar system. Some researchers believe that several planets have vanished from our system, but there's no way to tell where. Being so close to its star, the planet creates yet another interesting effect. Unlike most planets, it's not round, but rather egg-shaped. Since WASP-12b is 1.5 times heavier than Jupiter, but is almost 2 times larger, it has one of the lowest densities ever found. It is so low that the gravity on its surface is comparable to ours, being about 10 to 15% higher than on Earth. NASA's Hubble Space Telescope has observed a planet outside our solar system that looks as black as fresh asphalt because it eats light rather than reflecting it back into space. This light-eating prowess is due to the planet's unique capability to trap at least 98% of visible starlight falling into its atmosphere. The planet's atmosphere is so hot that most molecules are unable to survive on the blistering day side of the planet. Therefore, clouds probably cannot form to reflect light back into space. Instead, incoming light penetrates deep into the planet's atmosphere, where it is absorbed by hydrogen atoms and converted to heat energy. Hydrogen molecules are broken into atomic hydrogen, while alkali metals are ionized. The atmosphere resembles that of a low-mass star instead of a planet, composed of atomic hydrogen and helium. Using Hubble's Space Telescope imaging spectrograph, the international team that produced this result, led by Taylor Bell, has now measured an albedo of 0.064 at most, 2 times less reflective than our moon. But bear in mind that this planet's proximity to its host star keeps it tidally locked, with one side always facing the star and the other always turned to space. That drops night-side temperatures to well over 1,000 degrees Celsius cooler, so that molecules can survive, producing possible clouds and hazes in the atmosphere. Previous Hubble observations of the day-night boundary detected evidence of water vapor, and possibly clouds and hazes in the atmosphere. According to the study published in April of 2021 on efficiency of photosynthesis on Earth-like planets in the habitable zone, there is only one planet that comes close to receiving the amount of radiation necessary to sustain a large biosphere, and that is Kepler 442b. It is a rocky planet, about twice the mass of the Earth, which orbits a moderately hot orange dwarf star around 1,194 light-years away in the constellation of Lyra. The planet was discovered in 2015 by the Kepler Space Telescope when it was transiting its parent star. The exoplanet is about half the distance from its star than the Earth is from the Sun. It takes 112 days to orbit the star Kepler 442. Luckily, this planet is non-tidally locked, meaning that there are no extreme contrasts in the surface temperature. The planet is likely to have long days stretching weeks or months in Earth terms. The planet's mass is significantly bigger than that of Earth. Astronomers nickname it Super-Earth, alluding to the fact that it doesn't exactly have Earth-like mass, as this exoplanet is 2.36 times heavier than Earth. Kepler 442b's parent star is approximately 1,000 degrees cooler than the Sun and has only 12% of the Sun's luminosity. Despite this, the planet receives about 70% of the sunlight from its star that Earth receives from the Sun. The star is by at least 40% smaller and less massive compared to our Sun. Thus, it can live up to a span of about 30 billion years or so. For hypothetical life on Kepler 442b, this is good news, as it has enough time to evolve to complex forms. Overall, scientists are optimistic about the existence of life on this planet. According to an index developed in 2015, the exoplanet is even more habitable than Earth. Going to this index, Earth has a rating of 0.829. But Kepler 442b has a rating of 0.836. This is uncertain because Kepler 442b's atmosphere and surface are unknown, but this would be possible. Unlike Kepler 442b, Gliese 667cc is quite close to Earth, being only 23.6 light-years away. Presumably, it is a rocky planet located in the habitable zone of its parent star, Gliese 667c, meaning that it's just close enough to it to have liquid water. A red dwarf, Gliese 667c, is a part of a triple star system in the constellation of Scorpius, with stars Gliese 667a, b, and c orbiting each other, bound by gravitational attraction. Gliese 667c is the smallest star in the stellar system, with only around 31% of the mass of the Sun and 42% of the Sun's radius. Although the star is much cooler than the Sun, reaching a surface temperature of about 3,400 degrees Celsius, and being only 1.4% as bright as the Sun, it can produce enough heat to sustain potential life on Gliese 667cc because it is 8 times closer than the Sun to the Earth. The planet's relative closeness to the star is the reason why it receives 90% the amount of stellar flux received by Earth. The equilibrium temperature of the planet is 4.3 degrees Celsius, or 39.6 degrees Fahrenheit. For comparison purposes, Earth's equilibrium temperature is -1 degree Celsius, or 39.6 degrees Fahrenheit. Of course, this is only a theoretical model, and taking into account other unknown variables, such as the atmosphere and soil composition, the actual temperature can be very different. Gliese 667cc is sometimes also called super-Earth, owing to the fact that it's 3.8 times heavier and 1.8 times bigger than Earth. It takes 28 Earth days for the planet to orbit its parent star. Most probably, the exoplanet is tidally locked, with one side of its hemisphere permanently facing towards the star, while the opposite side is shrouded in eternal darkness. However, between these two intense areas, there would be a sliver of habitability called the terminator line, where the temperatures may be suitable for liquid water to exist. If the planet has a sustainable atmosphere which allows circulation of hot air, the habitable zone would include some areas on the side facing away from the star. Gliese 667cc has an Earth Similarity Index of 0.85 out of 1, which raises our hopes up in regards to the potential habitability of this planet. The good news is, this planet's star will shine for at least 100 to 150 billion years, which provides a lot of time for potential life forms to evolve. Kepler 62e is one of thousands of exoplanet candidates discovered by the Kepler Space Telescope, whose primary mission is to seek out Earth-like exoplanets outside of the solar system. It is located in the constellation of Lyra and has a diameter 60% larger than that of our planet. Its orbital period is 122 Earth days. This exoplanet is believed to be a water world, orbiting at about the equivalent distance of Mercury in its planetary system, some 1,200 light-years from Earth. The planet's nickname, Water World, is no coincidence. A modeling study concluded that Kepler 62e is likely covered mostly, perhaps completely, in water. It probably has a very cloudy sky and is warm and humid all the way to the polar regions, stated modeling co-author Dimitar Sasolov of Harvard University. The hypothesis that Kepler 62e is a water world makes it harder to imagine an advanced civilization on this planet. But there still could be fairly advanced organisms lurking in the water. Kepler 62e has an equilibrium temperature of -3 degrees Celsius, or 26 degrees Fahrenheit. meaning that this is how much, on average, it would heat up from the stellar radiation had the planet been totally black. However, given the fact that the stellar flux of this planet is 20% more than what the Earth receives from the Sun, it is possible that the surface temperature of this planet may be over 77 degrees Celsius, or 170 degrees Fahrenheit, which is enough to trigger the greenhouse effect, which would make the planet's environment hostile for many species. The parent star of the planet, Kepler-62, is a K-type main sequence star that is approximately 69% the mass of and 64% the radius of the Sun. It has a temperature of 4,925 Kelvin and is 7 billion years old. In comparison, the Sun is about 4.6 billion years old and has a temperature of 5,778 Kelvin. The star is somewhat poor in metals, containing about 42% of the amount of iron and other heavier metals found in the Sun. The planet has an Earth Similarity Index of 0.82 out of 1, which is pretty impressive. Earth Similarity Index is the estimate of how habitable a planet is compared to Earth. This number is calculated from the exoplanet's radius, density, surface temperature, and escape velocity, which is the minimum speed needed to break free from the planet's surface. Anything with an ESI above 0.8 may be considered Earth-like. For comparison purposes, Mars scores 0.64, while Venus comes in at 0.7. Tau Ceti F is a super-Earth orbiting Tau Ceti that was discovered in 2017 by the radial velocity method. Interestingly, its parent star is the only star in the constellation Cetus. Being just 12 light-years away, it is the closest potentially habitable planet orbiting a Sun-like star known to us. The parent star, Tau Ceti, is spectrally similar to the Sun, although it has only about 78% of the Sun's mass. The radius of the star is about 80% of the solar radius. The age of the star is 10 billion years, although other studies suggest that it is only slightly older than the Sun. The star is not as rich as the Sun in elements heavier than hydrogen, with only 22 to 89% of the Sun's abundance of iron. The star has a 34-day rotation period, which is quite slow. Tau Ceti F's orbit is equivalent to that of Mars in the solar system. The planet is 3.93 times heavier than Earth and is 6.6 times more massive. Tau Ceti F has an orbital period of 642 days. Compared to Earth, Tau Ceti F receives very little heat from its star, with a flux of 0.32 the flux on Earth. The equilibrium temperature of the planet is minus 83 degrees Celsius, or minus 117 degrees Fahrenheit, which is of course too cold for the majority of life forms. However, scientists argue that with the proper atmosphere and a large ocean, the planet's temperature might be similar to that on Earth. However, the new research has shown that Tau Ceti F has likely resided in the habitable zone for much less than 1 billion years, meaning that life hasn't had enough time to evolve and leave a detectable biosignature. Furthermore, the new study, which was published in the Astrophysical Journal, also notes that the star Tau Ceti has much more magnesium compared to silicon than the Sun does. As a result, the Tau Ceti worlds could be quite different chemically and mineralogically from Earth. A planet by the name of Gliese 581c. One of its sides is turned to the star, which makes it hot, the other side being dark and frozen. This is typical of most planets that are close to their stars. For example, the Moon circles the Earth and always shows just one side. So we couldn't see the other side of the Moon until the first outer space equipment was launched in 1959. There are gravitational forces at work. Our Earth has stopped the Moon from spinning and made it move synchronously. One circle around itself and one circle around the Earth, which makes only one side visible. This is called tidal locking. The Earth has hitchhiked the Moon. Any star hitchhikes its planet by gravitational forces in the same way. The closest planets orbit with one hemisphere facing the star and the other always staying in the dark. This is not unique to the planet we will be talking about. Gliese 581 is a very interesting exoplanet system. First of all, it borrows its name from a famous astronomer who has compiled a catalog of the closest stars in the 1950s. For the most part, we discover exoplanets of close stars because they are easier to discover. The star itself is a small red dwarf, which is much smaller than our Sun and doesn't give as much heat. But this star has a large planet system. At first, the scientists thought that it had 6 planets, but accurate observations show there are 5. One of these planets, Gliese 581c, has turned out to be in the so-called potentially livable area. Just to remind you, a potentially livable area is a narrow range of distance from the star where the temperature on the planet's surface is suitable for life. A sweet spot with conditions conducive to the emergence of life, if you will. But what do suitable or conducive mean anyway? A planet needs to have liquid water in order to be inhabitable. Therefore, a temperature should range between 0 and 100 degrees Celsius. Going beyond these limits means water either turning to gas over 100 degrees Celsius or ice below 0 degrees Celsius. This kind of climate makes a planet unlivable. So only the Earth is within the range of potential livability in our solar system. Venus is too hot. Mars is too cold, although it is at the edge of the area suitable for life. And in the system of Gliese 581, it was the planet C that has almost turned out to be a potentially livable area. It resembles the Earth very closely, with very few different characteristics. The fact that it is 5 times larger is not so critical. According to our estimations, the temperature on this planet ranges from 10 to 80 degrees Celsius. But why can't we give the precise temperature? We don't know the gas composition of its atmosphere. If it has a lot of carbon dioxide, it means the greenhouse effect would take place. Do you remember how the greenhouse effect works? The greenhouse is covered with transparent glass. It's warm inside and cold on the outside. Why is it warm inside? The sunlight goes through the greenhouse glass, warms up the surface of the soil in the greenhouse, but it can't get cold because of the heat being trapped inside. So, an atmosphere from the carbon dioxide would trap the star heat around the surface of the planet, which is why we have this wide temperature range. It's worth mentioning that 80 degrees Celsius is a very comfortable temperature for many organisms on the Earth, even though it's not for humans. Scientists believe that this planet is fully suitable for life, and it is one of the closest to us. It takes only 20 light years to get to. This might seem long to us, but it is really one of the closest stars. The closest star, Alpha Centauri C, is located within 4.2 light years, but this one is 20 light years away. If and when we learn to fly to the stars, we will visit planets like Gliese 581 first, because they catch our interest. The climate of such planets has to closely resemble that of the Earth, but you can always find a warm place on a tidally locked planet, a place which is neither too cold nor too hot. Needless to say, although the prospect of flying that far is not in the nearest future, interstellar travel can be a reality one day. Are you afraid of the dark? Welcome to TRES 2b, the planet of eternal night. Its mass is 1.49 Jupiters. It takes 2.5 days to complete one orbit of its star, and is 0.03563 AU from its star. Its discovery was announced in 2006. First of all, what is TRES 2b? As we already know, B means that it's the first planet discovered near a star. And what is TRES? TRESS stands for Transatlantic Exoplanet Survey. TRESS is about looking for planets through several telescopes operating from several Atlantic coasts in the United States and Europe. This is an amazingly interesting project. Do you know what kind of telescopes they are? People usually say astronomers have giant telescopes, but these are just extremely small. Their lens's diameter is 10 centimeters. And it turned out that by combining several telescopes like this into a network, they can observe the same star simultaneously. If one telescope is faulty, others will show the right image in such a way one can make an important discovery. So what did scientists discover? They found a transiting planet, a planet passing in front of its star. But after the transit, no data has been registered on this planet. TRESS 2b is located 750 light-years away from the solar system. When it was passing by the star, it dimmed its light just a bit and then went off the radar. But it shouldn't have. Starlight should have reflected from its surface and somehow show us the lit side of this planet. Instead, there is nothing. This planet has turned out to be the darkest thing there is. It reflects only 1% of the starlight reaching its surface. Look around and notice some black objects. For example, a computer case, a surface of an LCD computer display. Mind you, they reflect 5, 8, 12% of light. If you remember what soot is, the blackest soot there is reflects about 3% of the light. And this planet is at 1%. Its soil composition is not clear. The giant is absolutely black. This is truly puzzling. One reason could be an absence of reflective clouds, such as those which make Jupiter so bright, due to TRESS 2b's proximity to its parent star and the consequent high temperature. Another reason could be the presence in the atmosphere of light-absorbing chemicals, such as vaporized sodium, potassium, or gaseous titanium oxide. However, astronomers David Kipping and David Spiegel excluded heavy oxides of titanium and vanadium from their models, as it seems unrealistic that condensed, heavy compounds be present in the upper atmosphere. The planet is likely to be tidally locked to the parent star. In 2015, the planetary night-side temperature was estimated to be equal to 1,885 Kelvin. A planet by the name of HD 106906b. Honestly, this planet's mysteries challenge even the brightest theorists who can't wrap their brains around how this planet came to be. Its star is almost no different from the Sun. It's a little bit hotter, but otherwise, our Sun is very similar to it. What makes the planet mysterious is the super long distance between the planet and the star. For example, Neptune, at the edge of our solar system, is 30 astronomical units away from the Sun. This means that it exceeds the distance from Earth to the Sun 30 times. And that's it. There are no other planets past it. Astronomers seem to have understood why a long time ago, because the planets wouldn't have enough material to form. But this planet, nicknamed the Lone Wolf, is 20 times farther than Neptune. It's so far from the star that it's hard to imagine how it came to be in the first place. Just as hard as to imagine those distances. But let's just try. If we scale the Earth up to the size of a tennis ball and use it as the reference point, we would get the following numbers. The Sun would be about 1 kilometer away from the tennis ball and have the diameter of a 5-story building. And Neptune would be at a distance of 30 kilometers from the Sun. But this exoplanet would be 600 kilometers away from its star. Keep in mind that the size of the Earth equals the size of a tennis ball for the purposes of this explanation. Usually, the planets are formed the following way. A gas cloud is compressed by the gravitational forces, and the star is being born in the densest place of this cloud. and the remaining material is used to form the planets. But this one is so distant, there couldn't have been any leftovers. Researchers from all over the world were shocked by the distance between this planet and its star. They came up with an idea that the planet was stolen from another star. The thing is, stars form in groups. There can be a lot of stars in one place. Our sun was born in such a group a long time ago. So when one planet is formed around one of the stars, another star which could be passing by could pull this planet with its gravitation and steal it. This is why the idea of the lone wolf being stolen from another star makes perfect sense. But this theory comes with a problem. Because the 140-to-1 ratio seems to be on the extreme of what can be expected. The ratio of double stars is usually no more than 10-to-1. Even so, this hypothesis seems to be far more plausible compared to another alternative theory, which states that a satellite has been formed close by to the main object, and that it was subsequently thrown to the current distance as a result of gravitational interaction with another orbiting object. This second satellite needs to have a mass which exceeds that of the lone wolf, and the team who discovered it hasn't found such an object. Also, research has been published in 2015 that suggested that this planet may have been kicked out of its birthplace close to the star in a process similar to what may have happened early in our own solar system's history. The prevailing theory to explain how the exoplanet arrived at such a distant and strangely inclined orbit is that it formed much closer to its stars, about 3 times the distance that Earth is from the Sun. However, drag within the system's gas disk caused the planet's orbit to decay, forcing it to migrate inward toward its stellar hosts. The gravitational forces from the whirling twin stars then kicked it out into an eccentric orbit that almost threw it out of the system and into the void of interstellar space. Then a star passed very close by to this system, stabilizing the exoplanet's orbit and preventing it from leaving its home system. Candidate passing stars have been previously identified using precise distance and motion measurements from the European Space Agency's Gaia survey satellite. This scenario to explain HD 106906b's bizarre orbit is similar in some ways to what may have caused the hypothetical Planet 9 to end up in the outer reaches of our own solar system, beyond the Kuiper Belt. Planet 9 could have formed in the inner solar system, and was then kicked out by interactions with Jupiter. However, Jupiter would have very likely flung Planet 9 far beyond Pluto. Passing stars may have stabilized the orbit of the knocked-out planet by pushing the orbit path away from Jupiter and the other planets in the inner solar system. And so, this rare case has helped us to see this planet. It's so rare to take a real picture of an exoplanet. But this one happens to be so far from its star that its bright light doesn't interfere and makes the planet perfectly visible through a telescope. But there comes a question. If this planet is so far away, is it submerged in pitch darkness? Does it mean that the star doesn't shine its light on the planet? How do we see it then? The thing is, the star itself and the newly born planet, or the newly stolen planet, are both young and are still hot. When the gas cloud compresses, it becomes hot, just as any compressed gas. The planet is huge. It's approximately 10 times bigger than Jupiter. The surface of the planet is very hot, the temperature being about 1500 degrees Celsius. The Earth has existed for about 4.5 billion years, while this one is 13 million years old. And it will remain hot for quite a while and will be lit by itself, or by its heat to be precise. With infrared light, We have telescopes that can take even infrared images, also known as night vision equipment. We have taken a picture of this planet using such a device. The geographic outlines of this planet are hard to discern, but it is fully visible as a light source. This means we can study the chemical composition of its atmosphere and some other things. Scientists are working hard to study this lonely planet. What is also unusual about this planet is its orbit. The only telescope which was capable of gathering very accurate measurements of the vagabond for a few years in a row was the Hubble Space Telescope. Because this planet is far from its parent stars, it orbits them very slowly. The Hubble team was surprised to find that the remote world has an extreme orbit that is very inclined, elongated, and external to a dusty debris disk that surrounds the exoplanet's twin host stars. The debris disk itself is very extraordinary, perhaps due to the gravitational tug of the rogue planet. To highlight why this is weird, we can just look at our own solar system and see that all of the planets lie roughly in the same plane, explained Wen. It would be bizarre if, say, Jupiter just happened to be inclined 30 degrees relative to the plane that every other planet orbits in. This raises all sorts of questions about how HD 106906b ended up so far out on such an inclined orbit. The next planet on our journey is an exoplanet J1407b. At first glance, it's a spitting image of Saturn, a giant planet circled by a ring. It's not hard to get used to such an idea. We already know 4 ringed planets who are already engaged. For all we know, they might be married. Jokes aside, Jupiter has a very thin ring, just like Venus and Neptune, whose rings are barely distinguishable. And everyone can imagine a beautiful bright ring around Saturn. So far, there are no biggies compared to the kind of ring around this baby. The planet itself is quite young, just 16 million years old. It shines brightly with infrared light. It was discovered recently in 2012. It was among the first exoplanets discovered to have a ring. If it was Saturn, we wouldn't notice its ring. This planet has a ring which is 200 times bigger than that of Saturn. It's just gigantic. It could stretch as far as the distance between the Sun and the Earth. Such a gigantic ring around this planet. Of course, it has lots of matter. For example, if we would take all the matter contained in the Saturn rings, such as stones, snow, dust, etc., and put it in one place, we would get an object 200 kilometers wide, something like a small asteroid. But if we put all the matter from this planet's ring, we would get an object 1.5 times bigger than the Earth. There are several hypotheses as to how this planet came to have such rings. This planet might have destroyed another Earth-sized planet that it was passing by and borrowed so much matter from it that it couldn't have become a planet. But those are just theories. The ring itself is truly gigantic. Because the star is sometimes eclipsed by the planet and its ring, the planet's parameters have been studied extensively, such as its density and size of the ring. It was a matter of lucky geometry, which played out quite nicely. For the first time in history, we could see such a gigantic ring around this super Saturn. B means that A is the star itself. The planets discovered later are then called B, C, D, and so forth in alphabetical order. And here we have CoRoT T. What is CoRoT T? That's the name of a small outer space telescope. Surprisingly, this telescope was launched by French astronomers to orbit the Earth. Everyone was skeptical at first. What are those French astronomers thinking? To send a rocket and launch such a small telescope to orbit the Earth? The telescope is no bigger than those amateur astronomers have, 30 centimeters in diameter. But these telescopes observe the Earth's surface, and what they can do is limited. The same telescope in outer space can do much more. It can precisely measure the brightness of stars. If a planet goes in front of a star, partially covering its surface, the telescope will register it. And so when those astronomers who worked with this telescope discovered the seventh planet circling one little-known star in 2009, they realized that this planet resembles the Earth, but it was super close to its star. So close that it takes 20 hours for this planet to circle its star, something which takes 1 year for our planet. Just imagine, in less than a day, a planet circles its star. It is located in the constellation of Monoceros. It was the smallest exoplanet known at that time of its discovery, its radius being about 1.58 times longer than that of the Earth. The distance between the planet and its star is 2.54 million kilometers, which is 23 times closer than the distance between Mercury and the Sun. The fact that it's so close affects its temperature, which is 2.5 thousand degrees Celsius. Oh boy! CoRoT 7b is always facing its star with one side and has it in tidal locking. If you were to observe from the lit side of the planet, you would see a giant sun, 360 times bigger than it appears in our sky. A giant sun which is always in the ascendant and doesn't move. A sun with no sunrise or sunset. A little bit farther from the lit side, there is a relatively comfortable area. Here, lava becomes solid, making cliffs, and it's always dark. But this sweet spot is very narrow. Immediately, there comes the dark side of the planet, which faces outer space and doesn't see a speck of light. In contrast to hot Jupiters, which have gas structure, the temperature on the sides of this planet is on two opposite extremes. CoRoT 7b is made of stone, which does not conduct heat from the star. The dark side of the planet doesn't heat and always has a temperature of about minus 235 degrees Celsius, making it a lifeless, icy cold desert with eternal night. When astronomers calculated the planet's approximate density, it turned out to be over 10 grams per centimeters cubed. If you remember that the iron's density is a little bit less than 8 grams, you'll be astonished by this planet. 10 grams per centimeters cubed means it consists mostly of stone and iron. But iron is usually inside, just as it is with our planet. The iron core is then covered with stone. As for the atmosphere, it's clear that there isn't any. It's just stone. Think of the stone heated up to 2,500 degrees Celsius. What would happen to such a stone? The whole sunny side of the planet is like a huge boiling furnace. As it boils, it evaporates. The vapor goes higher, and high above, the temperature is lower than at the surface of the planet. The same goes for the atmosphere on Earth. Where we fly our planes, the temperature is minus 50 degrees Celsius. Here, it rains water, or sometimes it snows. But there, it rains cold, condensed stones. It rains freaking stones! Just imagine having stone droplets falling from the sky. This is amazing. This planet was nicknamed a planet of stone rain. One can just wonder where it came from. One idea is truly extraordinary. Once upon a time, this was a giant planet, much like our Jupiter. Once it came closer to the star, it was heated so much that the outer gas layers have evaporated into outer space, leaving an ironstone core. So it is thought it's a part of a giant planet. This was the picture that came to astronomers' minds when they saw this weird planet. CoRoT 7b is a world of extremes. Two opposite hells in one place. It's hard to imagine harsher conditions. "57 light-years away from Earth, in the equatorial constellation Virgo, one can see a bright pink spot. This is Gliese 504, a yellow dwarf star that belongs to spectral class G, much like our Sun, and has a mass equal to 1.22 solar masses. This star has a planet called GJ 504b. It's the one that steals the most attention. The distance between the planet and its parent star is quite long, about 8 times greater than from the Sun to Jupiter. At such a distance, the planet is poorly lit by its star. Nonetheless, the temperature in the upper atmosphere there is about 237 degrees. This can be explained by the young age of GJ 504b, which is only 160 million years old. For comparison purposes, our solar system is about 4.6 billion years old. It is estimated that GJ 504b is 4 times heavier than Jupiter. According to 2016 data, its radius is 0.96 of that of Jupiter. The exoplanet and its star are separated by a huge gap of 43.5 astronomical units. Just to keep this in perspective, this is equivalent to the distance between the Sun to Pluto. This comes as a surprise, because there are no such massive bodies at such a great distance from their star in our solar system. It still puzzles scientists to think about how the GJ 504b ended up so far away. In 2011 to 2012, astronomers working on the SEEDS project managed to capture images of GJ 504b and combine them into one image. It shows colored components in the near-infrared spectrum of the planet, orbiting a star similar to the Sun. The coronagraph subdues the bright light of the central star. The intensity of the radiation passing through the area is shown on the left, while the signal-to-noise ratio is on the right, showing even the weakest signal the system can detect. But there is another opinion regarding this object. In 2017, scientists published a study where they reassessed the fundamental properties of GJ 504 and its chemical composition. It has been established that the star is actually much older than previously thought. The study also allowed us to revise the data on the mass of GJ 504b, presuming it's heavier than we thought, which means that we are dealing with a brown dwarf and not a giant planet. As the journey takes us further, we will see a Jupiter-like gas giant, 51 Eridani b, at about 100 light-years from the Sun. This exoplanet is twice as heavy as Jupiter. It orbits its parent star, F-type 51 Eridani, in 32 years, and the distance to the star is 12 astronomical units. The discovery of 51 Eridani b was announced in 2015. The planet is about 20 million years old. Being relatively young, 51 Eridani b smolders at 427 degrees Celsius. However, it's still more than 3 million times less bright than its stellar host. In 2014, researchers captured a near-infrared image with the Gemini Planet Imager showing the Jupiter-like 51 Eridani b. The bright central star 51 Eridani is masked in the center of the image to reveal an exoplanet that is 1 million times fainter. The Gemini Planet Imager utilizes an integral field spectrograph, an instrument capable of taking images at multiple wavelengths of light simultaneously. The left side of the animation shows the GPI images of the nearby star 51 Eridani in order of increasing wavelength, from 1.5 to 1.8 microns. The images have been processed to suppress the light from 51 Eridani, revealing a faint exoplanet. The bright regions to the left and right of the masked star are artifacts from the image processing algorithm and can be distinguished from real astrophysical signals based on their brightness and position as a function of wavelength. The spectrum of 51 Eridani b on the right side of the animation shows how the brightness of the planet varies as a function of wavelength. If the atmosphere was entirely transmissive, the brightness would be approximately constant as a function of wavelength. This is not the case for 51 Eridani b, the atmosphere of which contains both water and methane. See the Jupiter-like planet orbiting its Sun-like star, 51 Eridani. So, judging by the chemical composition of the atmosphere, 51 Eridani b is the first known planet that almost completely resembles Jupiter. In 2010, following many years of observations, astrophysicists first filmed a video of 4 planets moving around the central star HR 8799, located inside the western edge of the large Pegasus Square. The star, with the first recorded exoplanetary system, is only 60 million years old. It belongs to the main sequence of spectral type A5V and is 128 light-years away from Earth. In November 2008, a team of scientists discovered 3 planets orbiting HR 8799 using infrared observations. The discovery of the 4th gas giant planet in the system was announced as early as 2010. In the same year, scientists managed to take a picture of the spectrum of one of the exoplanets called HR 8799c using the VLT telescope based in Chile. This was the first time this happened in the history of planetary science. All 4 open planets are gas giants. The orbital radius of the planet closest to the star is 51 AU, while the farthest has a radius of 68 AU. The orbital motion of the planets is counterclockwise. The 4 planets are still hot due to their young age. The mass of the farthest exoplanet, HR 8799b, is now estimated at 3.5 Jupiter masses, the other 3 weighing 5 Jupiter masses. For 7 years, astronomers Jason Wang and Christian Maroy have been directly observing the orbits of 4 planets in the HR 8799 system. And finally, they managed to make a unique animation based on a series of images. According to Jason Wang's description, the planets may well be in an orbital resonance relationship. In this case, the orbital period of each planet in the system corresponds to others with an almost exact 1:2:4:8 ratio. The black circle in the center of the image blocks out the star's blinding light to make the planets visible. HR 8799 is known as the first exoplanetary system to be captured in a detailed spectral resolution image, which is sufficient to calculate their orbital speed and understand the mechanism of gas giant formation. Now, let's move 300 light-years from Earth to the Carina constellation, where we'll find a young star, HD 95086. It's a Type A star, which is only 17 million years old. It is being orbited by another unusual gas giant exoplanet called HD 95086b. The exoplanet is 5 times heavier than Jupiter and has a complete orbital period of 328.8 years. It's 55.7 AU away from its parent star, which is twice the distance from the Sun to Neptune. The discovery of HD 95086b was announced in 2013. The planet was discovered by direct observation using the Very Large Telescope. HD 95086b was the first least mass exoplanet to be directly imaged in 2012 as a faint dot next to HD 95086. In the photo taken by the researchers, we see the sky of the southern part of the Carina constellation and the star HD 95086. Just right next to it is a gas giant, the planet HD 95086b. Using a differential technique to enhance the contrast between HD 95086b and the bright central star, the scientists got a clear picture. To improve the image of the faint exoplanet, the star has been removed from the frame. You can see its position marked in the lower left of the photo. The blue circle shows the size of Neptune's orbit in the solar system for comparison purposes. Thus, studying the formation pattern of HD 95086b at such a significant distance from the star indicates that the planet could have formed both as a result of gravitational instability in the protoplanetary disk and as a result of core accretion. In the case of the latter, it ended up in its current orbit as a result of migrating from the inner part of the planetary system, where theoretically there should be at least one more giant planet in a closer orbit. It's worth noting that all these planets were discovered using a direct method and are very large. It is believed that some of them may not be planets, but rather small stars, such as brown dwarfs, and only time will tell us for sure. First, how can we guess the type of climate, temperature, and rain on other planets? For example, does it rain stones or diamonds? How can we make a guess? The Doppler method allows us to estimate the planet's mass. The heavier the planet, the stronger it shifts its star. Furthermore, there is a method that helps to learn the size of a planet, but you need some luck to guess it right. Let's say we can observe solar eclipses from the Earth when the moon goes in front of the sun and overshadows it. Now, with a bit of luck, if the planet goes in front of a star, it would cover a part of the star's surface. It cannot cover the whole star. The planet is always smaller than the star. It always covers a star partially. During the eclipse, this makes the star reduce its brightness. It's what astronomers call the passing of a planet in front of a star or its transit. We call these planets transiting. One can guess the size of the planet based on how much brightness is reduced. This is how we know the size and mass. But what does this information give us? One needs to do some calculations. We start by calculating the average density of the planet. For example, in the solar system, there are two types of planets. Venus, Mars, and Earth are very dense. They are composed of stone with iron core, and the average density of these planets is about 5 to 6 grams per centimeter cubed. That means stone and iron. But there are giant planets. Their average density is approximately 1 to 2 grams per centimeters cubed, meaning they are composed of water and gas. By calculating the average density of the planet, we can estimate what kind of material it's made of. By learning the distance from the star, we can calculate its temperature. Naturally, the closer a planet is to the star, the hotter it is. Professional astronomers have a very simple approach. There are some catalogs. Each catalog contains either names of authors, for example, Gliese, or some abbreviations, for example, Bright Stars Catalog. A signifies the star itself. B is for the first discovered planet, and so on and so forth down the alphabet. So far, there haven't been identified any planet systems containing more than 8 planets. Of course, it's not very convenient for the wide audience to pronounce such specific names without fully understanding them. This is why the International Astronomical Union has recently decided to give the most interesting and well-studied exoplanets names of people, to give amateur scientists the right to vote and choose more or less interesting names. For example, one of the planets, which is a few times older than the Earth, was given a name of Methuselah, an old name of a well-known biblical character. Other planets borrow their names from famous scientists, but these names should be double-checked. So the International Astronomical Union receives suggestions on how to name a planet or a star. It may or may not approve of them depending on whether a particular name is worthy to be given to a planet or a star. For example, a planet by the name of Coro T7b. To estimate how many planets are in the Milky Way, we first need to know the number of stars. Unfortunately, due to the positioning of the Milky Way galaxy in the shape of a barred spiral disk, astronomers cannot observe all of the stars directly. Instead, they rely on the calculations of our galaxy's mass. Based on this calculation, scientists estimate that the Milky Way has between 100 and 400 billion stars. The next trick question is how we calculate the number of planets based on the number of stars. It should be mentioned that these calculations are pretty speculative. Although we live in an 8-planet system, this type of multiplanetary system is quite rare. Statistically speaking, most of the stars have 1 or 2 planets that orbit them. Some of the stars have none. And then there is also a type of planet called nomad, rogue, or free-floating planet. These are the planets that have been forced out of their planetary system during its earliest development stages. That is, when the system was gravitationally chaotic. These planets don't orbit the star, but rather the galaxy's center. Lastly, there are also stellar systems that have no planets in them, but rather smaller stars orbiting a bigger star. All of these facts determine the star-to-planet ratio in our galaxy. Based on this, scientists estimate that it harbors about the same number of planets, from 100 to 400 billion planets. But what makes a planet potentially habitable? First of all, let's get our terminology straight. Astronomers define potentially habitable planets as those located at such a distance from the star that would allow them to have liquid water. Of course, even though water is the main predeterminer of the existence of life, there are other requirements. Just like here on Earth, in order for complex life to evolve, a planet needs to be protected from space radiation by its atmosphere and magnetic field, as well as to have the right chemical ingredients conducive to life. Now, when thinking about chemicals that can be potentially used as blocks for living organisms, the first element that comes to mind is carbon, because it's what life here on Earth is based on. Although this is a predominant theory, there exist alternative ideas about potential silicone-based or germanium-based life. After all, other planets can host life so unimaginatively different from ours. To find life, astronomers look for gases emitted into the atmosphere that are detectable, like oxygen, methane, or carbon dioxide. However, it's not that simple, because even if one finds an oxygen-rich atmosphere on an Earth-like planet orbiting a distant star in the habitable zone, it doesn't mean that the planet is teeming with biological life. A water-rich planet that receives a lot of infrared radiation could have the water molecules split, producing oxygen molecules in the atmosphere. At the same time, astronomers don't discard planets that seemingly have very harsh conditions as definitely unlivable. Even rogue planets scattered across the universe without their home star can potentially host life. Before they were ejected from their star system, these planets could have possibly had oceans of water or atmospheres capable of sustaining life. Once they are ejected from their star system, these planets could still host life even if their respective stars never shine. If these planets have a sustainable atmosphere, they still might harbor life forms under the icy surface, which have warmed up from radioactive decay inside the planet itself. So how many planets in our Milky Way galaxy can potentially host life? This is a very debatable question, and numbers range from very high to very low across studies. High estimates are typically based on studies that only take into account the presence of liquid water on the planet. According to a research team from the University of Copenhagen, water is present in many planets as a part of their building blocks. This data was extrapolated from studies on how Earth, Venus, and Mars were formed. Their theory of planet formation is called pebble accretion. According to it, planets are formed by steadily accreting pebbles flying around the young planet during its earliest stages of development. Many of the pebbles happen to be made from carbon and water, which creates good conditions for the emergence of life. However, water can be dispersed very unevenly, Some planets can be too dry to host life, others can be flooded with it. Nonetheless, the research team does not give a specific number of potentially habitable planets, just stating that the chances of coming across a livable planet are very high. A more precise study published by Kunimoto and Matthews in February 2020 suggests there are 6 billion or so Earth-like planets in the Milky Way. By the term Earth-like, the researchers mean rocky planets roughly the same size as Earth, orbiting a sun-like star. According to their calculation, the upper limit of the number of Earth-like planets per sun-like or G-type stars is 0.18. This means that only 18% of G-stars have an Earth-like planet orbiting them. Considering that those stars constitute 7% of all stars in the Milky Way, and there are 400 billion stars, scientists have come up with a number of 6 billion. As for the other types of stars, the researchers haven't looked at them as closely. For example, they consider M-type stars to be too cold for life to emerge unless the planet is orbiting very close to a star. Stars around half the temperature of our Sun cannot sustain Earth-like complex biosphere because they do not provide enough energy in the correct wavelength range. At the same time, stars that are bigger and more powerful than the Sun can, in theory, power more photosynthesis. But these stars don't exist for long enough for complex life to evolve. That said, with the proper distance from any type of star, a rocky planet can potentially host life. It's just that it needs a number of other conditions conducive to life as well. A study done by NASA in October 2020 posits that there are only 300 million planets in our Milky Way galaxy that can be considered potentially habitable. The number is significantly lower than the previous studies because astronomers looked specifically at stars which emitted about the same amount of radiation as our Sun. The study was based on Kepler Space Telescope findings, which detected planets close to the size and temperature of the Earth. Some scientists go as far to posit the existence of over-inhabitable planets. That is, planets that have even better conditions for hosting life than Earth. According to a study by geologist Dirk Schulze-McCooch and astronomers René Heller and Edward Guinan, astronomers have identified 24 possible over-inhabitable worlds. What's promising is that one of these 24 planets stands out in particular and meets all of the criteria that scientists use to determine what makes a planet viable. However, all positive predictions aside, it is important to note that the planet can be habitable but lifeless because the origin of life never happened. This could be because the environmental requirements for the origin of life are much stricter than for the continuity of life, the study says. The most recent research on extraterrestrial life looks at whether the planetary conditions are suitable for photosynthesis to occur. Unfortunately, the numbers are getting lower. A new study from July 2021 revealed that almost none of the known exoplanets have the right conditions needed to sustain life as we know it. This study put strong constraints on the parameter space for complex life, so unfortunately, it appears that Earth-like conditions on other planets may be much less common than we might hope, said lead author Professor Giovanni Cavone at the University of Naples. However, there's no need to be pessimistic about the potential existence of life out there. One should keep in mind that planets can host life even under the surface, regardless of their conditions. For example, in caves, which would provide the temperature, humidity, and radiation protection needed to sustain life. And what's most important, we already know places on Mars where it's possible to go under the surface. Scientists have found some round entrances to vertical caves situated on the Martian shield volcano Arzia Mons. They are pretty large, about 100 meters in diameter. Such places are called sinkholes on Earth, and they are teeming with life. However, it's still unclear how we can send a machine there and get all the necessary data. And well, who knows what is in the depths of these caves? If you take this into account, it can significantly increase the number of potentially livable planets. Please subscribe to our channel and like this video.